Hello students, today we will continue our exercise, that is exercise 7.1. This is the exercise of standard 10, chapter number 7, coordinate geometry. So in this exercise we have studied up to the question number 6. So now the question number 7. And what is the question? The question is, find the point on the x-axis which is equidistant from, we have given the 2 points, 2 minus 5 and minus 2 9. So here we have to find a point which is on the x-axis. Again, it is equidistant from the two given points. Now think, whenever the point is on the x-axis, its y coordinate is 0, right? Okay, so let us take the 2 points, give the 2 points the name. The first point is A, 2 minus 5. Second point is B, minus 2 9. And suppose these are the 2 points. And the third point is, suppose there is on as equal distance between these 2 points, this distance and this distance are equal. That means AC is equals to BC. Actually, I have taken it all the 3 points as a linear on the same line, but it is not compulsory that all the 3 points are on the same line, right? Okay, this is just to understand the situation. Now this point is on the x-axis, that is why its coordinates is x and 0. Y coordinate is 0 because the point is on the x-axis. So let's suppose the point is C, x 0. Now this is the given condition that the distance AC is equals to the distance BC. Both the distance are equal. So when we apply the square both the side, so by squaring both the side, here we will get AC square is equals to BC square. Now we know how to find out the AC and how to find out BC using the distance formula. So here there is a square, so we do not need to write down the square root, right? So what is AC square? See, A is this point, C is this point. So x1 minus x2, that is 2 minus x whole square plus minus 5 minus 0 or plus 0, because it is 0, there is nothing to do with the 0, so let's take it to 0. Okay, so minus 5 minus 0 whole square is equal to BC square. So B is this and C is this, so again we can take here x minus minus plus, x plus 2 whole square plus 0 minus 9 whole square. So here by applying the identity, when we expand this, what we get? 2 square is 4, 4 minus 4x plus x square. This is the expansion of this identity. Here only minus 5 remain in the bracket, and that is a square. So minus 5 square is plus 25, that is plus 25. Now x plus 2 whole square, again apply the identity, we will get x square plus 4x plus 4. And minus 9 will remain here. So minus 9 square is what? It is 81. So now we have to simplify this thing. See here, x square is both the sides. So we can cancel out the x square. X square will cancel out each other. Okay, let us take this 4x to the left hand side. So minus 4x is already there. By taking this 4x to the left hand side, now we have minus 4x minus 4x. 2 times minus 4x. And by taking this 25 and 4, see again 4 is here, 4 plus 4 plus 4, again they will cancel out each other. So by taking this 25 to the right hand side, it will now become the minus. So 81 is already there, this 25 is now minus. So 81 minus 25 to the right hand side. So now here we will get minus 8x minus 4x minus 4x, that is minus 8x, is equals to 81 minus 25, that is 56. So by dividing the 8, we get minus 7 because minus sign is there. So by taking this minus 8 to the right hand side, it will divide the 56, and the answer we get is minus 7. So what is this? This is the x. And by putting this x value here, minus 7, we will get the required point. That is, therefore, the required point is minus 70. This point is on the x-axis, that is why its y coordinate is 0, and this point is equidistant from the point A and B. Understand? Okay. Now let us understand the question number 8. What is the question? The question here is, find the values of y for which the distance between the points P 2 minus 3 and Q 10y is 10 unit. See, one thing here we have given. One thing here we have given is find the values of y. Values of y means there is given a plural word, values. So here we can find more than one value of y. So here we have given one point, that is 2 minus 3, and second point Q, that is 10y. One more thing we have given is that the distance between these 2 points PQ is equals to 10 units. So we can write down PQ is equals to 10. So now by squaring both the sides, we will get PQ square is equals to 100. Now we have the coordinates 2, 3, 10y. Let us apply all these points here. Again here we do not have to apply the square root, because we here using the square, right? So PQ square is 2 minus 10 whole square plus minus 3 minus y whole square is equals to 100. So by simplifying this side, by applying the identity, we will get 2 minus 10 is minus 8, and minus 8 square is 64. Here by applying the identity, actually we will take the minus as a common, because both the terms are minus. So when we take the minus as a common and there is a square, that minus becomes the plus. So now 3 square is 9, or minus 3 square is also 9. Middle term is 3 to the 6 into y 6y. It is again plus, because both the terms are either minus, or by when we take the minus sign as a common, they both become the plus. And the third term is again y square. So this y square is here, 6y is here, 64 plus 9 is 73. By taking this 100 to the left hand side, it will become now minus. So y square plus 6y plus, these two terms remain as it is. 73 minus 100 is what? Minus 27. That is equals to 0. Now this is what we get, the quadratic equation. We can solve this equation by, we have to factorize this quadratic equation. So when we solve this, we use the splitting the middle term method to factorize this, and from the factorization we get the two solutions, right? So factorize the 27 such that the subtraction becomes 6, and that is 9 is a 27. So y square plus 9y minus 3y minus 27 is equals to 0. So instead of 6y, we write down 9y minus 3y. That you know now very well. Now by taking the common y as a common, here what will remain? Only y plus 9. And here by taking minus 3 as a common, again y plus 9 will remain in the bracket, is equals to 0. So by taking y minus 9 as again as a common, y minus 3 will remain. That is equals to 0. Now when we compare y plus 9 with 0, we get the value of y is equals to minus 9. And by comparing the y minus 3 with 0, we get the value of y is equals to positive 3. So these are the two values. One is minus 9, second one is 3. That is why in the question that is given that what are the values? We get the two values. One is 3 and one is minus 9. So when we put instead of y minus 9 and find out the distance, it will be the 10 unit. When we use instead of y 3, again we will get the same distance 10 unit. So in this way we can solve this type of questions using the distance formula only, right? Okay, so this is all about this lecture. Thank you.